Objective of this video is to determining the design shear capacity of 410 UB 53.7. So shear stress distribution of the web is approximately uniformly shear stress distribution, and hence use the clause 5.11.2 on page number 68. So generally the shear stress distribution in the web that is shown here. So that shear stress distributions are considered as approximately uniform. So what is that in the Australian standard? In the Australian standard on page number 68 on clause 5.11.2 is you can be used when approximately uniform shear stress distribution. So therefore we are using this clause. Now before I am going into the details, there is two equations that we can use to calculate the shear capacity based on these two conditions. dP on TW, left hand side is less than right hand side, the beam is fell by yielding, and if the left hand side greater than right hand side, it's fell by buckling. First we're going to check whether it's yielding or buckling. Based on this yielding and buckling, we have two equations that is given in the Australian standard. First of all, I'm going to show you where this dP on TW. So on page number 68 we have equations that is for yielding that I just pointed out here, that is for yielding, and on page number 69 we have this one for buckling. That is two equations. Now I'm going to point it out this one, yielding capacity VU VW. So that is on the page number, when we have this yielding, we can calculate VU is equal to VW 0.6 FY AW on page number 69. And if you have a buckling, VB alpha V VW, that is for buckling, and alpha V value equation is given on the page number 70, and that is alpha V value that I copy. So there are only two equations to deal with. So first of all, we're going to make the check. So left hand side dP on TW, that's the depth of the web. So for examples here we can have a I-beam, so that's I'm talking about, this is dP and we have this TW. Okay, so that we can get it from the one steel tables. For the 410 UB 53.7, 410 UB 53.7, depth of the web is given as D1, which is 381. So if you do the calculation, it's 381, or you can say that 403, that is total depth, divide minus 403 minus the thickness of the flange, that is 10.9, so times 2 times 10.9, 7.6, 50.1. even we can 410 53.7, even we can find 50.1 from the one steel table straight away. And 82 over Fy 350 is 320, but we are using grade 300, so therefore we are taking 300 megapascals. That is given 74.5. So comparing these two, 50.1 less than 74.8, then we are in the clause that this will fail by yielding, right? So we have this one dP on TW less than 82, so we are yielding. So yielding VU is equal to VW. So in clause on page number 69 we have a on page number 68, we have this dP TW VU is equal to VW. How do we going to find VW? We have a equation for VW. Equation for VW is given on the page number 69, VW 0.6 Fy AW. So that's we going to use it. So VW is equal to 0.6 Fy AW. 0.6 times the yield strength 300, and the area is 403. That is this one. I think it's 410 UB 53.7, and we have this depth is 403. Depth is 403 times 7.6, so that is given 551 times 304 divided by thousands give 551. So VU times VW is VU equal to VW is 551, multiplying with safety factor 496. So that's the shear capacity of that given steel beam, 496 kilonewton. Thank you.